It's my honor to introduce you to Fernando Perez and Brian Granger. I know that you guys are very busy lately, so it's nice that you made a space and visit us here. So enjoy the tutorial. Fernando Perez, I don't think he needs a lot of introduction. He's the creator of IPython. I've personally found this tool extremely useful for being productive in day-to-day scientific interaction with data, plots, or any kind of operations that you do regularly. And then there will be Brian Granger too, that will be helping you, I suppose. So, okay, so let's start.
Thanks for the invite. Okay, so we're going to spend just a few minutes going through. Is this working? Okay. Spend just a few minutes. Is the audio signal okay there? Okay. So I'm just going to spend a very few minutes on sort of broad introduction topics and a few links that you may want to have. As I said, if anybody doesn't have the tutorial materials, we have them on a bunch of USB sticks that are making the rounds. You can copy them from there. You should all have a raffle ticket in case anybody walked in late. We have raffle tickets here. We're going to raffle, I think, something like 8 or 10 books from a book that just came out about IPython, published by Pact Publishing. And thanks a lot to the Pact house that basically donated 10 copies of the book so we could raffle them to you guys. And the author, Cyril Rosson, did a great job with it. And then we'll dive into work. So hopefully all of you have everything installed. First of all, I want to point you guys to the main website for the project, and we're going to look at a few basic things. The first link that I want to point you to is this one that says Help Chat Room. That chat room is always available. It's our help room, and you can join in there. So what I would recommend is that you all open a browser window there, and if you have an issue, there's two options for us helping you right now. I'm going to be speaking for the first chunk, but in the meantime, Brian Granger, who Francesca already introduced, and Paul Ivanov, who's here, who is a Berkeley graduate student who is also has been part of the project for a number of years, will both be available to help you guys with any issues you may have. And so they'll be on the chat room, but if you need direct help, you can also kind of signal and they will come to you. And when Brian is speaking, I'll play the same role. So two of us will always be available either on the chat room, or we can come and give you a hand if you get stuck with anything. So don't fall behind, immediately ask for help, either there or call us. Obviously, if you have a broad question, feel free to raise your hand and ask for the whole audience. But if it's something that you just want to get unstuck with and you don't want to interrupt the discussion, either of those channels will work for you. So that's the first thing. IPython is a project that is a little weird. It's often difficult to really narrow its scope, but we're not going to spend a lot of time right now kind of discussing it. We're going to try to spend our time doing things. Very briefly, IPython was born out of the desire to have a better interactive environment to use Python. Python has an interactive shell, an interactive prompt. It's very, very limited. I was looking for an excuse not to finish my dissertation, so I started hacking on an improved interactive shell that was inspired by Mathematica and IDL and the Unix shell, and where I tried to combine basically the best features of those within the limited power of a student who still had to finish his PhD. So a lot of the things that you see in IPython today appear disconnected from that, but in reality, all of the lineage traces back to that question of having an efficient interactive environment to compute and manipulate your code, your data, see what you're doing, and have a record of what you're doing. Originally, it was a terminal-only project. Today, we have things like the graphical Qt console. We have things like the web notebook that we'll be using extensively. We have things like parallel computing support. All of those are still tying back to the notion of working interactively, computing things, and having very rapid access to your results. And so there is conceptual coherence in the project, despite the fact that it appears to have so many faces. I invite you to peruse the website. A few important links. As I mentioned, the book This is a physical copy of the book, and some of you will get one. I think the author did a great job. It's not only about IPython. It's basically a quick introduction to doing interactive scientific computing centered around IPython, but it briefly introduces NumPy and Matplotlib and SciPy. And the publisher actually donates a small fraction of the proceeds back to the project. So basically, whenever you buy a book, you're making a small donation to IPython. We have our help chat room, which is, as I mentioned, a good venue for today, but it's persistent. We're not always there, but we do our best. If you want to ask questions about IPython, our two main channels are either Stack Overflow and simply tag your question with the word IPython. Just go to Stack Overflow and tag your question with the IPython tag. They're easy to find, and we do our best to answer questions there. And we also have a mailing list. We used to have two mailing lists, one for users and one for developers, but we've sort of mothballed, not completely deprecated, but we've sort of mothballed the user list, and we've kept the development list as the single project list. The reason is that we want to really stop kind of putting people in the bin of I'm either a user or a developer. We would like everyone to think of themselves as a stakeholder in IPython. Maybe one day you're using it and you want to figure something out. Hopefully the next day you'll have an idea and you'll be contributing to the project, and you should be able to move back and forth in that spectrum in a very continuous way as your interests and needs dictate. So we're having one single project list. We didn't want to change the name of the lists. These lists are 10 years old, so we just called it dev, but we don't link to both lists anymore anywhere. We also have a wiki with some information about the project. There's a Reddit, for those of you who use Reddit. A user, we didn't do this, but a user created an IPython subreddit where useful links are posted periodically. And very importantly, file a bug. So if you find a bug with IPython, by all means, please file one. Our open bug count is a little painful, closing on 600. At one point, I had hopes that we would never cross the 100 open issues barrier. That ship has long sailed, unfortunately. What's that? But yes, there are a lot of feature requests, and we do have a pretty decent closing record. You see close to 3,000 closed issues. So we do our best to stay on top of it. And by all means, file an issue if you find a problem. And then in the same HipChat environment, we also have a development-oriented chat room. You're welcome to join in the conversation anytime, as well as some tools that are really oriented for the developers, such as the status of our continuous integration bots in Shining Panda and Travis, but we don't need to go into that very much. So very, very briefly, from that perspective of doing interactive computing, IPython provides terminal-like environment, a terminal-based shell that does the things the basic Python shell does and lots more, as we'll see in a minute. A web-based notebook that many of you probably have already used and that we'll be using extensively. Integration with GUI toolkits and management of the event loops and whatnot. That's kind of a somewhat obscure-looking feature, except that that's what makes it possible to have things like an open plot window and keep on typing, right? And so it happens to be super important for scientific usage. All of the machinery in IPython can be embedded into your own codes, and we'll see how to do that. This is meant to be an in-depth tutorial, so it's not just about the high-level features. We're going to go into some technical detail on how you can use IPython as a component in your own projects. And finally, high-performance tools for parallel computing. We're going to cover some of that at the very end, but it'll be a fairly high-level intro. Parallel computing is a complex enough topic that we could not conceivably cover all of the rest of IPython and that even in 4 hours. In previous years, we've had an entire 4-hour tutorial just on the parallel stuff. And that's already a pretty intense tutorial. So what we'll do is we'll demo some of the features and give you a flavor for what's available there. So finally, if you're looking for kind of more, in addition to this tutorial, for more detailed examples of what you can do with IPython and what all the pieces are, in addition to extensive documentation, whoops, what happened? In addition to extensive documentation that we do have, and videos of similar talks and tutorials to this one, we do have a collection of notebooks that basically explain a lot of IPython that is shipped with IPython, and there's a link to it from the front page, and you can view any of these. And we have a gallery of interesting things that people are doing with IPython, and this is somewhere, a place where we simply track interesting topical work in science that is being done. So you may find here things that catch your attention or things that you can learn from. And there are some really, really beautiful things being done. I just want to highlight one of them. This is a long list, so I'm not going to spend too much time on it. But this is actually an entire book on Bayesian methods and MCMC, which is being written. The whole book is being written as a collection of IPython notebooks. So the book is a GitHub repository, which is fully executable. You can clone the whole book and basically learn about Bayesian statistics and computational Bayesian methods by executing the code. And if you look at any of these notebooks, what you get is something that really reads like a book with very nice typography, with all the mathematics in there, with all the code, the math, all the code, and then all the figures. So you can read a book on Bayesian statistics and run the book while you're learning. And so these are the tools that we'll be using. And the place where you're seeing, if you look at the URL that I was pointing out for the book, that URL is part of IPython. And so, whoops. It's called nbviewer at ipython.org. And nbviewer is a web service that the project runs and that you should know about, because whenever you have an IPython notebook that is publicly visible somewhere on the internet, it doesn't matter where, if you want to share it with a colleague and you simply want to share the read-only version of the notebook so that they can see it, such as the page I was just showing you for the book, right? I'm not executing this notebook here, I'm reading it. Then all you need to do is paste the URL of that notebook in here, and then we will render it for you. So it's a web service that in real time will grab whatever notebook you have and render it into a readable version for someone else, but it will always include a link so that they can download the actual file. So it makes it very, very easy to share work based on IPython with friends and colleagues. The only restriction is that it has to be visible online. This is basically a web service that wraps our notebook conversion machinery, which is also available at the command line. But in this case, because the installation of prerequisites is a bit complicated, we made it available as a web service. So that's sort of the overview. And the only other thing that I think is important that we check now at the beginning is whether everyone is okay with the installation. So installing IPython these days is very straightforward. Both Anaconda and EPD/Canopy from Nthought have a complete up-to-date version of IPython. For every other tutorial that you guys are going to be following here during this conference, you need actually more than IPython. Every other tutorial has more dependencies than IPython, so chances are you already have it. But I want to run a quick check of hands. Does anybody not have it installed? Because you're going to be using it. Okay, it sounds like everyone is okay. And all the up-to-date Linux distributions also have the same version. So everyone, if you have a problem with getting it started or running, please call us. We do know that if some of you happen to be on Windows with particularly aggressive versions of security software that blocks ports, we know of one, which is this thing called Sophos, firewall/antivirus that causes problems. And there are certain ways of configuring port access and whatnot that may cause trouble. If you are on Windows and you're seeing bizarre behavior with the notebook, ask us on the chat room. We'll post a link to some of the solutions. If you don't have admin access and you can't change anything on your computer, because we know that has happened to a few other people in the morning, then the best we can do is set you up with an online account from Continuum. Has a service that basically runs the notebook in the cloud, and then you can use it remotely. That's the best we can offer. And Francesc, maybe I can help creating the Wakari account for you. So if you, but this should only be a problem kind of in that subset. You are on Windows and you have very aggressive firewall stuff that you can't deactivate even for an hour because your machine is fully locked down and you don't have the administrative control. Okay. So having said that, I'm going to stop the overview and we're going to try to dig in. We're going to try to dig into using the IPython notebook. And so let me actually do this from this terminal. And let me close everything that I had open so that I start from scratch with you guys. Okay. So, is that font large enough Or should I make it even a little larger for the video and for the people in the back of the room? I can make the font larger if it's needed, or is that okay? All right, it seems like everyone says it's okay. So this is the tutorial material, which that's one link I should give you guys. I'm running on a fresh profile, so this is the URL for the tutorial. It's on GitHub. IPython/IPython in depth is the name of the repository. We have sent a link to it. You should either git clone it now, or you should have done that before. If you did git clone, do a git pull. We added some new material about an hour ago. So if you cloned it a few days ago, please do a git pull right away so that you have everything that we have here. If you don't have Git installed, don't worry. You don't need it. You can click on zip here and download a zip file with the exact content of the repository as it is. And we also have it on the 7 USB sticks that are floating around. So everyone should have this material. If you do have it cloned in advance and you do want to run with me a small parallel computing demo at the very end of the workshop, then please copy a directory called images, which is in the USB sticks, or download images.tar and unpack it in the notebooks subdirectory of the tutorial from Perez. Let me write this down here. It's just a bunch of images, fperez.org/tmp/images.tar. Just download and unpack that into the notebooks subdirectory of the tutorial. So it should be images here. That's only if you want to run it with me. And since this is going to be mostly demonstration, you don't have to, and you can do that later during the break. We have the 7. I just forgot to put that last week. I'm sorry about that. I'm sorry?
What was the git clone command?
The git clone, if you want, what's that?
It's in the chat.
It's in the chat? Okay. Are you logged in the chat room? Okay. So those kinds of things are perfect to do on the chat. And actually, if you can post these URLs in the chat, that'd be great. Because then you can copy and paste rather than me saying things and you trying to copy and paste from my voice. You can copy and paste with your mouse. Okay, so I am going to assume that you guys all have this checked out or copied. And then in a terminal, so this is that directory precisely. And here I will go to the notebooks subdirectory, right? And first of all, I'm going to run a very quick check before we even start the notebook. If I type IPython, I should get something like this. And you should all get something that looks like this with IPython 013.2 and a prompt that looks like that. If anyone gets any kind of error message at this point, please say so, and we will do our best to help you. Because if this doesn't even start for you, we have a real issue. 13.1, yeah. No. For the 0.12 would be bad. 13.2 has some small bug fixes over 13.1, but you will be able to open all the files. If anyone is on 0.12, we do have an issue. Any other questions? Which we can solve, but any other questions? You have a question in the back.
When it couldn't load current magic,
The
module for magic.
Oh, the current profile? Okay, ignore that. It's a small bug in the nthought version of the distribution. You can ignore it. As long as it starts. Does it start? You just get a nasty warning? Yeah. Just ignore it. Yeah, they took that out from the current version of the distribution, but it's an old bug in their configuration. Okay, were you asking a question, sir? No, okay. So I'm going to get out of here. Clear. And now this is what I want you to type. IPython Notebook. We're going to switch directly into working in the notebook. I'm going to type IPython Notebook, and you should see something like this. A few print statement, a few commands, and then it should say that it is running a notebook at this URL. Oh, actually, I'm sorry. Let me make sure that you don't need the profile SciPy. That's because I have many configurations of IPython, and I want to make sure that I'm using a clean one for this tutorial. So So I switched to tell IPython start with my clean default configuration for the tutorial. IPython allows you, and you will see later how to do that, to define this notion of profiles that are basically ways of configuring IPython so that you keep everything for one project or one topic in one area. So when you say that, you should be able to now open a web browser and point it to that same URL that was printed here if it didn't open by default. I have it configured so it doesn't open by default, but for you it might have opened by default. And then you should see every notebook that is in that tutorial should be listed there. This is what we call the notebook dashboard. This is the area where you create notebooks. And so before we dig a little bit deeper, I'm going to give you a very, very quick feel for what the notebook looks like, just so that Brian is going to describe it in much more detail. The notebook itself, but I need to explain the bare minimum so that you know what you're doing before we even get to Brian's in-depth explanation. So if you click on New Notebook, you get something that looks like this. So you should think of this as a terminal, like a mini terminal there embedded, but in an area, in an environment that is kind of like a word processor. So imagine you had a word processor with text and pictures and whatnot, but that could have little mini terminals embedded in a page. That's kind of a simple mental model that you can work with. So if I type here, oops. Okay, computer, do not do this to me. Okay. I don't know why that window was not accepting any keyboard input from me. If I type some code and I hit Shift-Enter, then that will execute that block of code as if I had done it in a terminal. The reason why you need to type Shift-Enter is so that you can put more than one line of code and use Enter to edit more than one line of code. Okay? That's the basic of executing code in the notebook. And as I said, I'm not going to go into any more depth now because Brian will explain that in the next segment. But at least you need to know what to do in the most basic things. And the other notion is that in addition to these little terminal-like areas, one of these areas can be changed into a text area. And we typically do that using the markdown syntax. And so as you see in the explanatory notebooks that we're going to be working with, as you see normal text that doesn't look like code, that will be because it was created as a markdown cell, which this is kind of the word processing part of it. It allows you to mix text that's not comments in code, but normal text with the little terminal-like blocks of code execution. And Brian will explain to you how to format your text and all that.
So,
Yes?
the appearance of the notebook I have is got a panel on the left and doesn't have a menu on the top.
Okay, so Paul is going to come and give you a hand with that because that means you have 0.12, and that is going to be an actual issue. It means you have a really old version, and then a number of things that we need actually will not work for you. So Paul will give you a hand. Does anyone else have that? The notebook with a weird-looking sidebar on. Basically, it doesn't look like this to you. It has a sidebar with some buttons on the left and no menu bar at the top. If any of you has that look, please let Paul know, and he will come and give you a hand as well, okay? But we can't stop the tutorial for that, unfortunately. Okay? Any other questions? Yes, you have a question.
On dashboard, can I change the folder?
Directory?
Yeah.
No. So unfortunately, that's a really awkward and we know annoying limitation of the notebook. We are in the process of fixing that annoying problem, but you can't. Which means that what ends up happening is you go to a terminal and then you go to a different terminal and you type IPython Notebook. And when you type IPython Notebook again, it will open it in a new port. So what most of us end up having is multiple notebook servers running on adjacent ports. It always begins on 8888, and it keeps looking for the next one available, okay? Yes, we know it's clunky. Yes, we're fixing it, but that's the way it is right now, okay? It turns out that as silly as it sounds, fixing it is fairly complicated. And so the fix will be a little bit of time coming, but we're working on it very hard. Any other questions? And yes, it means it gets a little confusing because you have to remember which port, like in which browser do you have which one open that corresponds to which directory you started it in. So it is a little more than a little suboptimal. Any other questions? Okay, So now let us begin with an overview of IPython. That is called, IPython Beyond Plain Python. So I want you to click on the IPython Beyond Plain Python notebook, and you should get this. You should get something that looks like this, okay? And so if I hit Shift-Enter, I can execute code. And what I want you to do is work with me. We have a lot of material to cover, so I'm not going to type every single line, but we're going to work through it together and we'll make small changes. And there is some explanatory text in there to try to help you. Is the font size, let me make maybe the font a little bit bigger. Maybe even a little bit bigger. Okay, how is that font size looking for those in the back? Better? And also for the video capture? Okay. And I'm going to do one thing. So the header at the top simply says when the file was last saved, the name of the notebook, and just a logo. I'm going to toggle that out so that there's a little bit more vertical space for you guys to see since I'm zooming in the fonts. It's just more useful for presentation. So Shift-Enter is the main mode of executing code. You can also execute code with Control-Enter. And if you do Control-Enter, the cursor does not move to the next cell. So the reason why that's useful is if you want to type something quick and keep changing it, to work more in a terminal style, instead of building up a bunch of stuff, you're kind of working in place. You just want to check something quick. Instead of Shift-Enter, you can hit Control-Enter. And unfortunately, this is only true in newer versions of the notebook. The 013.2 did not have the Alt-Enter, which executes and inlines a new cell right below where you are. We found out later that that was a very common pattern, to go back somewhere and start executing and injecting new space to work. So this comment right here doesn't apply, unfortunately, to this version. It's true in the current development branch. So for now, you have Shift-Enter for executing basic code, and Control-Enter if you want to execute but stay where you are to keep making changes like print. Okay? Now, normally when you hit Shift-Enter, the code block executes, and the cursor, in this case, the cursor outline indicates where I am, moves to the next cell. Okay? So the basic IPython, as I said, is a superset of the Python prompt. And so I'm assuming here, this was built as an intermediate tutorial in the sense that we assume you know what the basic language is. I'm not going to explain the basics of the language. I assume that you guys know how to use Python. So I want to show you what is different in IPython that Python doesn't have, right? This is where we're starting. And so the first thing is, we tried to make IPython a very useful tool so that you can get information out of the system while you're working. And one of the things is, how do you get help? So if you simply type question mark in IPython, that will trigger machinery that gives you help. And what happens is IPython opens this pager at the bottom that you can drag and resize with additional information, okay? So this pager is used to display information to you when there's a lot of it. And you can drag its size if you want it out of the way. And if you simply want to dismiss it, you click on the bar and it goes away. The bar is actually available down here. So I can restore it by clicking on it again, and I can dismiss it by clicking on it, okay? So that guy may pop up on and off as you're doing things and requesting information. And when you simply type question mark, IPython tells you a little bit about what it is. I'm not going to read these things in detail because in a sense the tutorial is that information, but I just want you to know that it's available there. And if you don't remember the most basic stuff, you can type question mark and you'll find out about it. Now the question mark is actually a piece of machinery that is pervasive in IPython. And so if I have an object that I would like to learn more about, like say I'm reading something about the collections module in the standard library and I want to know what is a name tuple, all I have to do is type the object name and name tuple, question mark, and then IPython will open the same pager with information, but in the case of an object, now it tells you a lot more. It tells you what kind of object is it, what file is it defined in, what is the definition line of its constructor, if it's a function or a class constructor, and it shows you the docstring of the object. So whenever you type for any object, you type question mark, IPython basically digs into the object and analyzes it and tells you back things about the object. So most of my learning of how to use libraries and stuff is done by using question mark. Now, If I want to know more, I can type 2 question marks. And what that does is it tries to dig deeper. So instead of summarizing information, it'll actually show you the source code for the object. So this is actually the entire source code for the name tuple object in the Python standard library, which I find extremely useful because it's a great way of quickly grabbing the source of anything. This does not always work because the source code for everything is not always available, but as long as the source code can be found, we'll show it to you and it'll be, as you saw, syntax highlighted and whatnot. Okay? And then finally, the question mark can be used together with wildcards. Instead of giving you information about one thing, it can give you information about a group of names. So for example, if you want to know what are all the names that have the word int in them that you have currently available, you can type *int* question mark and it'll find all of those names. If let's say that I import numpy as np and I do np *cos question mark, if I want to find out what are all the things that have cos in NumPy, well, then it'll tell me that there's both things that begin with cos, but there's also things that have cos somewhere in it. So the question mark is this very versatile thing. You can do single question mark, double question mark with wildcards to dig into objects, into libraries, into properties of things, and it's a very useful thing to get used to. Now, IPython, in addition to the bare question mark that gives you sort of an intro, once you've read the intro, if you want to just a set of mnemonics of what IPython does, you can type %quickref. And quickref gives you basically a cheat sheet, a quick reference card for IPython that summarizes a lot of what I'm going to tell you. You don't need to read it all right now. A lot of what I'm going to tell you today and what Brian is going to cover today is summarized in the quick cheat sheet that has all of these things. So I encourage you to remember that it's there. So basic question mark and quickref are your 2 sort of handy intros in addition to reading our manuals and whatnot. Okay, there's another part of IPython that has received an inordinate amount of attention. You wouldn't believe how much code has been put behind the tab key on your keyboard. The tab key on your keyboard has been weaponized to a pretty extreme level in IPython. And so we have very extensive and very aggressive tab completion machinery that does lots and lots of fairly complicated things for you. And in addition, that machinery is extensible to you. So you can actually define your own tab completion machinery to introspect your own objects. And that sounds silly, but it turns out that it saves enormous amounts of time and you get into a very fluid flow by using tab completion. So when you tab complete in IPython, it will tab complete and show you, in this case, in the notebook, it'll show you a list like this. If you're working in the terminal, it'll just print it'll just print the list to the screen. The tab completion, as usual, works if you've typed a few more letters. So if I do this, and now if I do this, it'll only give me the things that begin with a capital I. But this tab completion will work across files, across commands, across Python objects. It'll work across the scope of the block of code you're editing. It'll actually find text in that block that you've typed that may not even be defined yet because you haven't executed it, and it'll use it to complete. So it's so get used to doing tab a lot. Yes, you have a question?
Dependent on your browser?
It shouldn't. Which browser are you using?
I'm using Reconc on Ubuntu.
Yes, that may, we are pretty, what's that? Yeah, when you go that far, I would recommend that you use, Chrome is the browser that has the best behavior and the best JavaScript support. Firefox also does work quite well. Chrome or Chromium on Ubuntu, but Firefox works equally well. Other more exotic browsers, the support rapidly drops off like a pretty steep cliff. Honestly, Reconc, I have no idea. We do know that up until Internet Explorer 10, previous versions of IE did not work. IE 10 works well. Reconc, probably not, I'm afraid. IPython makes very aggressive usage of lots of JavaScript, lots of WebSockets, lots of really new things in the browser world, and the more exotic browsers may not support that feature. Okay, so as you're working and going about your life and computing things, actually I do have this gizmo here. Right, in case you want to use it later, there's also a laser pointer here. So what are these numbers, these in and out prompts. Well, obviously in and out means whatever input you typed and the output it produced. But the point is they have numbers. These numbers are available to you to represent the history of what you've been doing. Python by default, whenever you compute a result, even in the plain Python shell, Python automatically creates a variable called underscore, which is the last answer that came out. So whenever there's an output thing, that thing will be stored as underscore. Okay? So if I do, right, underscore is now 1002. But we've made a few changes to IPython in that if you put a semicolon at the end of the line, you suppress the generation of output. And that seems silly, except that in our world of scientific computing, quite often you will be doing things like calling something that produces a plot, but also returns some junk that you actually don't care about. Matplotlib actually returns a lot of internal data structures, and 90% of the time you don't need them. But what you want is the figure. So by putting a semicolon on the last line, you will suppress the return of that output. And this is something that is not part of Python. This is something that IPython does for you. Right? In plain Python, the semicolon is valid, but doesn't do anything. It's a no-op. So we've kind of hijacked it to allow you to control interactive output. Okay? Now, these in addition, another thing we did is that in addition to the single underscore, and this was inspired by other computing systems such as Mathematica that I was a heavy user of when I began working on IPython, that memorize everything you've done so far. So in addition to having the underscore remember the previous value, anything you've computed earlier and that has a number is remembered as underscore and that number. And it's also remembered as out. The out variable is actually not just the cosmetic prompt here. There is a variable called out. And so underscore X number and out and that same number are the same thing, okay? And the reason for naming them underscore is just because they're quicker to type and more convenient. Out is a little bit more verbose and clear. So you have a cache of all of your outputs as either out and number or underscore and number. These are automatically created for you. Now the obvious question is, does that stay forever, and does it mean that I'm keeping all these big variables potentially forever? And the answer is not quite forever, but yes. And that's an important point to be aware of when you use IPython. Because of this caching mechanism, you are keeping, we have a limit. I think the limit when we flush that cache is 1,000. It's configurable. I think the default is 1,000. But unless you have a session that generates more than 1,000 prompts, you're keeping all of that in memory, right? Since that is potentially a problem, you may want to say, flush all of that stuff, but don't destroy my session. Obviously, you could quit, but you may want to just free some memory. There is a command called %reset that will do that. And the reset command will once I run reset, now underscore 16 is gone. So the reset command will flush all of these internal caches for you if you ever need it. I point that out because every now and then people get bitten. This is a convenient feature, but every now and then people will get bitten by it. So the %reset command will do it. And so, and just for the sake of completeness, in addition to single underscore, we actually keep 2 and 3 underscores. We didn't go beyond 3, but we do keep, so 2 underscores is next to last and 3 underscores is next to last result. So in case you're doing something, I often use it as a calculator, and basically these things are handy. It's like you've added a bunch of numbers and like, oh, I want that and that and that, and it's just quick and convenient. In addition to the out, just like you see in and an out and a number, you see in and a number. Well, it turns out that we also have an in list. That is the inputs you've typed. And just like you have underscore in numbers, we have underscore I. So underscore I is the previous input, double I is the next input, triple I is the next one. And so your input history is available. And the reason why that may be useful, it's not as necessary in the notebook because you can copy and paste real blocks of code. But if you're ever working on a remote server just over the terminal and you don't have really decent block editing, having access to the stuff you've typed can come in very handy. And these are real, this is real code. You can execute this stuff. Let me see. So you can execute that, and it'll execute just like, yes?
How would you execute it like in the same way IPython would? So if it had some magic and do something, then except wouldn't work.
I don't think we have the translated history stored in a convenient data structure like this. So there's syntax in IPython which is not valid Python, obviously. These percent commands, for example, that's not really Python syntax. So the question that Aaron is asking is how would you execute the real version if you have that kind of syntax? Well, the way we run it, the exec command would not work because exec expects valid Python. Yeah, for now, you could do, this might work. Now I'm ad-libbing here, but yeah. So what I did here is, there is always a function called getIPython, which gets you the actual IPython object itself, the interpreter that is running your code as a Python object. And that object, this is a bit more advanced, but we're actually going to see this a little bit later. This object has a method called runCell. That's the method that runs your own code, right? And so what I did in there was get a hold of that and pass it a block, because that's the main entry point for IPython itself to run your own code. That's the method that applies all the necessary translations. So that's how you can do it. Oh, well, okay. And so, have I forgotten anything? No.
Sorry, did you say there was a method to insert a new cell?
Yes. So if I'm here and I would like a new cell above where I am, I can say insert cell above or insert cell below. And there are also keyboard shortcuts for all of these things in here. So Brian, are you going to cover some keyboard shortcuts?
Yes, all of them.
Okay, so Brian will explain them in more detail. I've been doing a little bit of that as we go just because I sort of need to, but I don't want to go into detail into it. But there is a menu there that gives you those, and in a half hour, Brian will go over them in detail. We have a bit of a bootstrap problem that we need to explain. The notebook is the best environment for explaining what IPython is, but we also have to explain how to use it in depth. So I'm trying to give you the bare minimum to get going, and in an hour, Brian will cover it more in depth. So, especially if you're at the terminal, there's a command that is very useful called %history. %history gives you the history of everything you've done so far. So it's very handy if you want to grab a bunch of stuff you've been doing and copy paste it into an editor, especially if you're at the terminal. The history command takes a bunch of options, okay? You can pass it a bunch of options, and if you want to find out what the history command does, okay, you can ask it with question mark as well. So if you type %history question mark, it'll tell you what the options are and what they do and so on and so forth. So I want you to run a small little exercise, which is write the last 10 lines of your history to a file named log.py. And I'm going to give you guys just a couple of minutes to do that. So find out how to call it and try to write the last few lines of your history to a file named log.py. And this kind of thing is actually quite common if you're working remotely in a server at a terminal and you want to dump a bunch of your stuff. If somebody gets it, please raise your hand. I want to use the popcorn method once I see a few kernels popping. Anyone else? The last 10 lines. Write them to a file named log.py. Okay? Okay, I'm going to give it a little bit more, and then I see a few people are getting it, so but keep trying. Okay, so I know that not all of you have gotten it, but some of you have, and I want to show you how you could do that. So if you look with question mark at the explanation of the history, you see that it has a -f file name argument and an L number argument. And if you scroll down a little bit, you'll see, -L and number means get the last n lines. So if I say -L 10, that should give me my last 10 lines only. And now if I say -f log.py, that should write those lines to a file name log.py. Okay? Now, the next topic, accessing the underlying operating system. So one of the things that IPython tries to make easy and useful is that you should always be able to access the OS without jumping through big hoops. Yes, question?
So I did that.
Uh-huh.
I do exclamation mark cat log.py and I don't see it. Is that a problem in which direction I do? No such file.
Not there. Paul? Did Paul leave? Brian, do you think you can see if does cat, for those of you who think you got it, does catalog.py work?
Doesn't for me either. I just raw Python, not the.
It works, but I used save.
What's that?
I used save to write to the file.
Oh, that's weird. Why would this not work for you guys? I'm actually running the same exact version. I'm running 0.13.2. You typed it like this.
Can you see if you actually created a file though?
Excuse me?
I ran that command and it executed it, so let's see the file was created.
I think I know what makes it wrong. It's the order in which you have your arguments. If you dash in log twice first, it works. So in your example here, you just cut that right in front. You don't see the word after I pick it that way.
So this works, is what you're saying.
There you go.
And I wonder why it worked.
You had one previously.
Oh, I might have an old one. Okay. Okay. And I happened to show you one, but because obviously I've run these examples before, I had already, and we were looking at a stale file. Good catch. Okay, so our command line parsing for these things has more order dependency than it should. It should, so that should be considered a bug in IPython, that we shouldn't, that order dependency should not exist. These arguments are independent of one another. That order dependency should not be there.
So I'm using 1.0 dev, I think.
It's fixed?
Yeah, it seems to be.
Okay. So it was a bug which we fixed in between. So don't report it again since it's fixed. Thank you. Okay. So this was a good segue into how did I check that file by typing exclamation. So whenever you type exclamation, IPython will let you run the rest of the line directly in the underlying operating system immediately. And that's because we need that a lot. And Python makes that kind of convoluted. So if you type pwd, I get this. But we actually take that a little bit further. You can do things like exclamation, but make an assignment on the left. So if you do exclamation and a command, but make an assignment to that, instead of simply running the command, we capture the output of the command. So this lets me capture the output of the ls command into a Python variable. And what we do is we capture it into a list broken by new lines. So we actually thought quite a bit about how to capture, and we decided that the most natural data structure would be a line-oriented data structure, so you can iterate over it line by line, like most Unix tools that iterate line by line over text files. Okay? So And furthermore, when you run anything with an exclamation, if you want to interpolate back a Python variable, you can do it. So the files variable is a Python variable. But if I want to, this is using the Python command print files. If I want to call the echo system command on Unix, then I can actually say echo $files, and it'll actually interpolate the Python variable back into the command. And so the reason why this is handy is because I can never remember the syntax, the godforsaken syntax for looping and logic in bash, right? But I do know the name of many commands in bash. So typically when I need to do something quick and dirty, what I do is I do all the logic, the complicated logic in Python, and then I create variables that I need, and then I make simple system calls with exclamation and expand out the variable. So we've created this kind of hybrid between the shell and the language where you can go back and forth between the two. And it's a little nasty, but it comes in quite handy. It's a kind of very practical tool that is super convenient and a huge time saver, even if somewhat unholy in its lineage. And you can actually go pretty far. With a simple dollar, you can only expand names. But we use the Python templating syntax. So if you put curly braces, then you can actually put arbitrary expressions inside of that call. So that lets you really go quite far in terms of what you do, because you can make system commands calls with complicated logic embedded right in there.
So that's just like putting system import system from OS.
Yeah, it's just making that for you in a convenient interactive syntax, especially at the shell. It just saves time. Okay, so this is one of the first very obvious directions in which IPython does things that go way beyond what the language would normally be doing for you. Obviously, yes, everything we do is implemented in terms of Python code. So all we're doing is basically translating your input into what are typically rather boilerplate heavy things and saving you from the boilerplate. So the next topic is called magic function. So you've seen already that these have already come up a couple of times, these commands with a % sign at the beginning. Right? I hadn't really explained what they were, but we saw quick-ref, and we saw reset, and we saw history. Well, we actually have a cornucopia of these things, and they're called magics. And it's again, like everything else in IPython, it's extensible, it's accessible to you. You can define your own magics. And the point of the magic syntax is to give you a way of defining commands that are separate from the variables and syntax of the language, so that you have a layer of control commands that you can use on top of whatever variables and code you have running at any given time. And because the syntax is in valid Python, it'll never get in the way of the normal language, right? So it's basically a control layer sitting on top of the language that's always accessible. And so if you simply type %magic is another one of these references that explains the idea behind the magic system so that you can see it right there. I'm going to read all of this to you. But basically in IPython we have sort of 3 quick information dumps. Basic question mark is like, okay, the most basic, what do I do? Quick ref is the cheat sheet, and magic is the cheat sheet of the magic system that kind of summarizes what it is that they do. And the way magic commands can do pretty much anything with their input. So their input is not restricted to being Python code. It's not restricted to being a Python variable. For example, the history command, you already saw it. That was taking command line flag like a Unix system call. It wasn't, you don't call them with parentheses and quotes and commas. And you can write them to do whatever they want with the code. A very commonly used and popular magic is the time it magic. You want to time how much a block of code takes to run. You type %magic. And it'll run that code using the Python time it machinery and report on the execution time for that block of code, for that line of code. Now, yes?
What happens, for instance, if I happen to have a variable that is called magic, magic?
So what happens then? So if I have a variable called magic, which is the number 1000, right? And I type magic, I get this. If I type %magic, you get the right thing. So the % allows you to disambiguate between the two. Now, if there is no magic variable, it turns out you can actually omit the %. So if there is no conflict, you can omit the %. And at the shell, I often omit it. In the notebook, because I save these notebooks, I tend to write it sort of in long form by always doing the %. But the value of the % is that it lets us disambiguate between the two namespaces. Any other questions? Okay. Now, a magic by default with a 1% character only extends until the end of that line, okay? But we have the concept of what we call cell magics, where if instead of 1%, you put 2%, it actually extends to the entire cell. Now, this is really beyond what the language can do, right? And so these special double percent magics can only be the very first line of a cell. Not just the first executable line, no, the very beginning of the cell. These things, we basically special case the syntax and we look for a line. If the cell begins with double percent something, then that's a cell magic. If it's anywhere else, it doesn't work. So this lets me run 2 time-it calls, right? Run a time-it call on the entire block of code. But it has to be at the beginning. If I do this, you get something else, right? The time-it is ignored, and then it executes the rest of the stuff. So, yeah.
So why does it only put the output of one of the commands?
When we have, okay, that's a very good question. What is the output that is put here? Because what we return is it's the return value of evaluating this. It's not a print. If I had put in here print statements, you would see both, right? If I had put print statements, you would see both. But if I do this, we only, and what are we doing? This is a bit of an advanced question, but it's an important one. If you have a complicated block of code with lots of stuff going on, what is it that comes back? What we do is we actually analyze the abstract syntax tree for that whole block, and we split it into independent execution units. And we find what is the last independent execution unit of the block, and we only return the value associated with the last execution unit, rather than every single one of them. And the reason, and only if it's a single expression. The reason for doing this rather convoluted logic is that if we did it otherwise, and you have, for example, a loop that makes plots, then you would get, each of those things actually generates an output value. And so you would start getting not just all of your figures, but there would be like 10 outputs. Imagine you run 10, you would get out, and we actually experimented with that, and it was very absurd. So there's a complex heuristic at work here, but it's a heuristic that has been excruciatingly fine-tuned for what we think is a good usability pattern in the long run, okay? I remember long conversations we had on the phone on this. Like hours and hours and hours have gone into fine-tuning this heuristic.
So if I do want result,
Give them a variable name. That's what variables are for, right? I mean, what we decided was rather than auto-creating gobs and gobs of these things, if you really need to keep track of 10 things, you should name them something, right? They should be variables. This is a programming language. This automatic capture is just for whatever just came out at the end, right? We didn't want to go overboard with that. Okay? So, because line magics are completely unambiguous, you can actually use line magics in the middle of code. So this is really going beyond what Python does. But you can actually use line magics in the middle of a block of code, right? So there I'm actually calling, and you can also use exclamation in the middle of blocks of code. Right? This is pretty nasty, but there you go. So we're in the middle of a block of Python code. We're making a system call that's expanding a Python variable into its shell and calling the shell with it. So yeah, you can do some slightly excessive things with Python, with IPython. Okay, so now that we've opened, we'd like to think so. Now that we've opened up this kind of worms of the double percent, then you can pretty much let all hell break loose through that, because you can do whatever you want in those blocks. And we provide you with a fair amount of machinery already, but you can define your own magics, and Brian will cover how to do that later. For example, we have a built-in magic which is called bash, which simply calls bash with a block of code. So if you find in the middle of a notebook, you need to call a chunk of code from a script you had, but you want it to be documented in one single environment, you just prepend it with double percent bash. And it'll really call bash. And in the body of cell magics, we don't do any of this fancy dollar expansion or anything, because that would break the syntax very easily. So that dollar expansion is only done on line magics. But we let we let the dollar, for example, there, this is $shell, the system $shell. We pass the block of code unmodified to the underlying shell so that you can copy arbitrary scripts and they would work just like if you had run them at the command line, okay?
I'm assuming that blows up on Windows? Or
Yes, so there is no bash on Windows. I don't know, I mean, an equivalent CMD style or BAT style command could be written to call the underlying Windows command batch executor with this. It's just that we have more manpower on Unix class environments than we do have on Windows. IPython itself is cross-platform, so it's only this that doesn't work on. And I imagine, actually, let me take that back. If you have Cygwin bash installed in the path, it probably would work just as well. Because the only thing we do with this is call that program with the body of the code. So if you had bash, and bash is available for Windows via Cygwin, then it would work. You can imagine somebody writing a PowerShell, like $% PowerShell, so that you could type PowerShell scripts in there and execute them in whole blocks. Okay, so because often you use IPython remotely into servers that you don't otherwise have other access to, or you don't want to SSH and OpenVI for, we've created a magic which is called file, and actually it now has a different name, right? What did we end up choosing? Save as? Over? Write file? I don't know. Anyway, we changed, the name of this $% file has slightly changed. It'll continue working, it's just that you'll get a warning that says now the new name is so-and-so. I forgot what it is right now. But the point is, what this command lets you do is type a body of code and dump it to a file with a given name. It doesn't open that file, it writes the content of that file. So the use of this is if your only entry point into a remote server is a notebook, and you have little chunks of stuff that you want to leave on the file system as text because maybe some other command line tool needs to use them, or whatever, or you need to copy and paste a little bit of CSV data because you're going to run a command on top of it, this is a convenient way of basically having snippets that get written out to the underlying file system. So it seems like a bit of a weird thing to have, except it proves to be very convenient. And it's completely destructive. Every time you run it, it saves that data in it. It really is meant to clobber the operating system, the file system. Okay, so I don't have time. Yes, question.
Is that on the IPython shell, not on the notebook? There's some way to do that?
So in the basic shell, it will work, I think, in the terminal, but it only will work if there's not more than one blank line. In the break, I can look into it. The issue is, in the default terminal, there's no easy way for us to know when to stop taking input and when to execute it, because there's no there's no event handling that lets us distinguish between I'm typing stuff and I want to run it. Here, in the Qt console and in the notebook, we have both ShiftEnter, ControlEnter, all that. We have access to all the key bindings. We don't have that in the terminal. So we have a heuristic that tries to guess when you're done. And combining that with this concept of cell magics is really hard. So the terminal, the notion of cell magics sort of works in the terminal, but up to the fact that the input termination heuristics may fail. The underlying machinery is there, but the heuristics for what constitutes complete input may be kind of funky. And partly that's because when we only had the terminal, we didn't have cell magics. We wanted them, but we knew they would not work well, so we never bothered implementing them. It was only once we had the Qt console and the notebook developed that we went back into this problem and designed the cell magic machinery. Okay, so if you want to find out about other magics, you can just type ls magic. And ls magic will tell you, it's like ls for magics. It shows you all the magics that are currently available. For any of them, you type ? and the system will tell you about it. We don't have time to go into all of them, as you can imagine. Okay. A few more things, and I'm going to wrap up in about 5 to 10 minutes when we finish this. I'm going to go quickly through this. If you want to run Python code that you found somewhere, you can actually paste it even with prompts. Look, I just pasted something from the tutorial with input prompts and everything. We strip all that for you. So we go through, and the same thing if it has IPython prompts. Okay, so if you need to quickly copy and paste something from somewhere to see what it does, you can do it wholesale like that, and we still run it for you. What do errors look like in IPython? Okay, I'm kind of covering all the things that you can do in IPython that you cannot do in Python. So I just wrote mod.py. It's a little file that defines two functions, and depending on what I call it with, I'm going to get an error because I want to show you what errors look like. So if I call g of 0, it should produce a traceback. So this is what an IPython traceback looks like. They're a little bit more detailed than default Python traceback. We syntax highlight, and we print much more information than you normally get. And again, all of this is trying to help you while you're working interactively to get as much information out of the system as you can. You can change how exceptions are reported. If you type xmode is a magic that changes the exception mode, this is the default. If you say xmode plain, they look like this. They look a lot more like a normal Python traceback. The reason that plain mode exists is in case you want to copy and paste the traceback, say, into a plain tutorial or into a doc test or into something where this additional information may not be what you want. So you can turn that off by saying plain. You can also say verbose. There's 3 levels of exception reporting. So this is the default. Plain is the simplest one. And there's one with even more information called verbose, which, as you see, shows you at every frame in the stack the values of every called parameter and every value, every variable in there. The reason we don't make it a default, the default, is because this may be too much information. You may get huge dumps of data on the screen. Maybe a variable is expensive to compute its representation and it takes forever. So we don't make it the default. It's potentially expensive. But you can toggle it anytime you want more in-depth and more detailed data quickly. So you have the 3 exception reporting modes. Context is the default. So I just set it back to being the default. Okay, so this is just to show you another way in which you can do things in the notebook in IPython that are, and all of these things work the same. I'm using the notebook as the environment. All of these things work the same at the shell. Okay, so obviously as scientists, we need to look at data a lot, and IPython provides and has provided since almost the beginning of Matplotlib, tight integration with Matplotlib in many ways. And there is a special magic called %pylab that loads Matplotlib, but it doesn't just do an import. It loads it in ways that work well with IPython. So rather than simply saying import Matplotlib, you should always use %pylab to load Matplotlib support. And when you load Matplotlib, you can give it a parameter to say, how do I want to use Matplotlib? Do I want to pop windows where I can pan and zoom? Or in the notebook or in the Qt console, you may want, instead of popping floating windows, you may want the figures to be saved as part of the document. So if you say pylab inline, then we will load the inline figure machinery that we developed that takes Matplotlib figures, but instead of putting them in a window, embeds them directly in the Qt console or in the notebook output. So as you make your plots, your figures are right there, and then the workflow is very natural. Well, you start making your changes, you change your parameters, and you keep executing these cells until you get sort of the figure that you're interested in. And these figures are saved as part of your notebook file so that they can be reused. And those notebooks that I showed you on NBViewer, that's everything they do. So this is a quick overview of the main points in which IPython goes beyond the language. There's a lot more, but even in a 4-hour tutorial, there's a limit to how much we can cover. Yeah. Oh, with standard Matplotlib, I mean, the Matplotlib figure size parameters, the RC params, I mean, I'd have to. What's that?
Would you import
I'll put it in the chat.
Okay, great. Yeah, if you can put it in the chat. Yeah, you would pass the Matplotlib figure size. So the place to find it is go to IPython.org.
Oh, okay, it's not a SciPy thing.
Right here.
It's not the conference thing.
No, right here. Go to IPython.org and click on that. Okay, that's the help room, and when Brian shifts to work to speak, I will log in, and Brian and Paul are logged in right now. So, and you can ask questions kind of through the side channel, and you can help each other if you want to take a minute to chat.
But I want to use IRC.
Well, so we used to have an IRC channel, but we switched to this partly because it gives us persistent logs, which are very useful for the team to have persistent logs without having to bot the hell out of an IRC channel. And it also gives us something very handy. In these channels, if you mention someone and that person is not logged in, they get a ping in their phone and they get an email. So when we need each other quickly in the chat room, we can ping each other, and IRC, I mean, I'm sure you can bot the living daylights out of it, but this is $1, this costs like $4 a month to the whole team, and believe me, it's better to spend our time on this, on making IPython better than on writing IPython IRC bots.
The other nice thing is that a lot of the government servers block IRC. So like, for example, I wouldn't be able to get to IRC.
Oh, really? I did not know that.
Yeah.
Whereas I'm sure this they don't block because the NSA has a full log of it for their convenient analysis. So they're very happy that you use this instead. And for the record, no, we do not encrypt it in any funny way. So don't put anything in there that you don't want your friendly NSA mathematicians to analyze. And it is logged. I mean, actually, that it is logged is something we wanted. Because when we log into it, oh, I'm not authenticated. This is. When we log into it, we being the developers who have persistent accounts, we get the option to do this, which is this is the help room where you guys all are, but we can go up here and say load more history. And we start seeing. We can see previous history, we can keep going back and we can search it. So it's very useful for us to have. And the other thing that is great about it is that it has GitHub integration. So as there's activity on our issues and bugs and pull requests on GitHub, automatically we get notified on the development channel. So it's a very handy way of integrating our own discussion with what's happening in the issues on GitHub. So, and sure, all of these things can be done if you spend a month customizing IRC, but we've got better things to do with our time. Whatever. Okay. So finally, before I hand it over to Brian, how is this notebook doing what it's doing, and how was that different from when I opened, I've got this thing full screen. How was that different from when I had in here when I typed IPython and I ran simply right there in my terminal the code? Well, what we've done is basically we've taken the entity that does this, that runs in your terminal and takes your input. We've taken that piece of code and we've stripped it of the assumption that it's talking to your keyboard and that it's printing to your screen. And instead, we've replaced the keyboard input and the screen output with network ports. And then we've put a piece of code in front of it that channels that information back to the web browser. It's exactly the same code that runs in the terminal, and that's why everything we've said, modulo a couple things that have to do with the messiness of event handling at a terminal, are exactly the same. The syntax and everything else is 100% the same because it is the same thing that runs in the terminal, and that proves out to be very useful. You can actually find out where that object is on the network and talk to it. So there's a magic called connect info. And if I run the connect info magic, it actually prints for me the information about where this thing is alive, about where this thing is connected and working. And there's a magic called Qt console that will open for me a Qt console that is connected to the same exact process. So I was running in my notebook, but obviously there had to be an IPython thing behind. And if I want to connect to that same IPython from a different client, I can type Qt console and it'll find the connection data, open another, and this Qt console is like a terminal, but it's a graphical terminal. And so if you see the prompt right here, this was prompt number 70, this is prompt 71. If I type history, I see my history right here. I can type mod I can type plot x, y and get my figure. So this is like a terminal, but it is a terminal-like widget that actually allows embedded graphical output. And it is talking to the exact same piece of code that was executing already my code. And so you can open multiple clients simultaneously to the same engine. This seems to be a little bit of an opaque capability, but it proves to be extremely useful in many contexts. an important one for you guys, or for those of you who need to do parallel computing, is that because all the parallel computing uses the same things, you can actually connect clients directly into your engines to do interactive debugging in parallel scenarios. So this can come in quite handy. You are talking to the same exact engine. So if I go here, if I go here, this is the figure. If I say f is oh no, I need to. Yes. So if I create, in this case, what I did was I made sure that I grabbed a handle on the figure itself from matplotlib. By default, matplotlib doesn't give you the figure object. So if I grab the actual figure object and I have it here, you can see that this is actually, you're working with the same, you're working from two different places against the same namespace, against the same underlying computing entity that is running your code. So this is kind of the more abstract part of the presentation, which is now explaining to you how all of this is operating, because you have this thing in the back called the IPython kernel, which is running, and that the web browser is talking to, but that you can simultaneously connect to from somewhere else. You can also connect to it from a plain terminal. You can say IPython console, and you pass it this connection data right here, and you can connect to it not only from the Qt console, but also from a plain terminal console. So yes, question.
Did you use that to, I mean, how would you use that to connect from remotely running IPython session?
Well, it depends on exactly, if you have an I mean, you obviously need to have an existing client that gives you this information. So let's imagine that you're running this thing. What's that?
Running a notebook in my office and connecting from home.
Well, that's a slightly different question, because you can actually run the notebook on a public IP with SSL encryption and password protection. So if you want to run a remote notebook, you really want to use the full capabilities of the notebook, right? And Brian is going to show you how to do that later. So that you can do. This is if you want to talk to the underlying computational engine directly. And the two main use cases are if I want to do stuff quick and dirty, scratch work that I don't want saved in the notebook by default, but where I want to play with the same data. I often will, in my office, will have the notebook here and one or two of these Qt consoles right here. It's the same data, it's the same variables, right? But here I'm doing kind of the scratch work, and in the notebook I'm kind of leaving. So it's sort of the difference. I don't know how many of you used to work this way, but when I was in grad school, I did a lot of work with two scratch pads. One in which I would take a little bit more elaborate notes, and if I'm working on a nasty piece of algebra, I would grab a piece of scratch paper, scribble, and once I figure out what I needed to do, I would go back and kind of write it more cleanly. And so this is one way to use it, sort of the quick and dirty non-saved scratch pad and the notebook file that has the persistent notes with explanatory text and titles and so on and so forth. And the other big one is in parallel computing environments. Because if you have 128 nodes running something, and something weird is happening on node 72, being able to say on node 72, give me this, and start plotting on node 72 is very, very handy. Right? Connecting directly to the namespace of one out of 100 engines, and right there start playing with the data without any of the overhead and any of the complexity of managing an entire parallel computation can be enormously valuable. Okay? Any other questions? Yes?
Yes, but if you're in your scratch pad, you start changing your variables, it'll change it in the...
Absolutely. It's one namespace. It's one Python interpreter. Yes. If I change a variable here, so this is x right now is an array. If I say here x equals hello, right? X is hello. Now I go back here and I say what is x? Now it's hello. These two things, it's the same kernel, right? It's the same process. There was one more question here?
Yeah, if someone is trying to compromise your system by putting the shell command in the log file, how do you counter that?
By putting what?
Shell commands for, like, let's say if someone's trying to add a RM or some shell command in your log file, how can you counter that?
In your dot file?
The log file.
Well, whenever you run, I mean, you should.
I mean, if someone gives you the log file and you execute that, but suddenly there is some imperfective code in that file.
So the question is for the video recording, what about security? If somebody gives me a notebook file, right, and they put embedded in a block of code rm-rf $home, right, what about that? Well, you should treat notebooks like scripts, right? Notebooks are effectively code. And so just like if somebody mails you a Python script and you run it without looking at it, and I mean, they could put os.system rm-rf $home, right? It's the same exact thing. And a notebook has a code payload in it. I mean, that code payload also has text and figures and whatnot, but there's code in there. And so you don't go run all notebook on a random notebook that you don't trust, right? Because yes, it is code, and it's just the same thing as saying if somebody mails you a bash script and you just run it, what if it does rm-rf $home in the 150th line? Yeah, it'll destroy your home directory. But in this regard, a notebook is a glorified Python script, or Python plus Bash plus Ruby plus Perl plus everything else. Okay, so I want to hand it over to Brian, unless, yes, one.
So when you changed X in the other
Mm-hmm.
console, that didn't get registered in the notebook?
It didn't get registered in the notebook document.
Right.
It got registered in the namespace. Those are two different things. The notebook document, you should think of the notebook document as a log of the things you've done, right? So there's a distinction between the document itself, right, which is what you want to save, what you want to type, and the underlying data, which is why I was calling it the scratch space, because it lets me modify the data in memory and play with things without saving them to the file. I think of the notebook as a document, right?
So when you go back and you change something that you wrote before,
Mm-hmm.
then you sort of save the notebook. What you wrote before doesn't get saved.
Well, the document gets saved. I guess maybe I'm not understanding exactly.
There's on line 69 there or whatever, I go and change that and write something else. Does the previous thing get saved?
Well, so if here I now say x equals 100,
Yeah.
right, and I run this, now that changes, right, and this is what will get saved.
Right, so what was there before doesn't get saved.
No, I've overwritten it. Yes, yeah, you only save what you're looking at. Yeah, the notebook doesn't save everything that has been run. The notebook saves what you see, right?
So the history of the stuff that got run
This history.
is gone.
Well, no, it's not gone. It's stored in the thing that the history database accesses.
It's gone once you've saved the file and you've gone down to.
No, because this is actually accessing an SQLite database. So there is an SQLite database that has the history under the hood. You can actually get the history from previous sessions, and you can actually access and you can mine that SQLite database. It's an entire SQLite database with all of the input history from every session you've had. But the document is only what you want to keep, what you're looking at. One more question?
How do you start inlining figures off? You do it on the fly?
On 0.13.2, you can't. You have to choose when you start PyLab inline or non-inline. After we released 0.13.2, we added that capability. So now you can do, I'm running 0.13.2 for the tutorial, so I can't show it to you, but you can do PyLab inline, and later you can type again PyLab Qt, for example, and then you switch from inline to Qt. And then you can type PyLab inline again. You can only go back and forth between one. You can only do either inline and Qt or inline and WX. You can't go between GUI backends, but you can switch back and forth. But that was added after 0.13.2. Question?
This might be answered a bit later today, but if you're writing a script, how can you tell that you're running inside a notebook?
You can't. Brian will explain. Or are you going to talk about that? Or I don't want to keep monopolizing the conversation. So no, you can't, because again, this model of a kernel and a client is such that, remember, as we were showing here, the notebook and the Qt console are both talking to the exact same kernel. That kernel is being simultaneously managed by a notebook and by a terminal. So there is no such thing as running in the notebook. The kernel is just a kernel. It's controlled from a notebook, but it can be simultaneously controlled from a terminal. So there is no such thing as it is running from a notebook. The notebook is one client of many possible. This is like saying, how does a web server, a web server can check which client is accessing it at any given time, but it's simultaneously accessed by multiple clients. And the kernel is no different. It's a server that is accessed by multiple clients.
The reason I ask this is I've got an interactive tutorial that runs in the terminal, and then in order to rewrite it to run from that point, it sounds like I've got to start from scratch.
Well, yeah, there's some copy and paste involved, I'm afraid. Depending on how you wrote that interactive tutorial, we can maybe we can take it during the break or after, and we can look into it. But yeah, there is some rewriting. Believe me, we've been rewriting our stuff. What's that? Short 5-minute break? Okay, that's a good idea. Maybe let's take a quick 5-minute break.